Hey y'all, so today we are going to be going over whether or not a relation is a function. So we're looking at this page right here where it starts off with function or not notes. A relation is a set of inputs and outputs that are related in some way, meaning a set of x values that when you do whatever equation it is, gives you a set of y values. So we have a set of inputs and outputs related in some way, x and y values. So these are just x and y values that are related to each other in some way, meaning there's some sort of equation or expression between them. So a function is when a relation has one y value for every x value. So one output for every input. Meaning that if I plug in a number for x, I'd only get one y value. There are 4 different strategies we'll use to determine if a relation is a function or not. But let's look at the first 3. Relations can be written in a number of ways. Right here, we're given a set of ordered pairs, meaning in the coordinates basically. So x comma y, these are ordered pairs. So sometimes we'll be given ordered pairs written like this. Sometimes we'll get them written like this, or sometimes we'll get them written like this. And the question that we are asking ourselves is, do the x values repeat? So in order to be a function, none of the x values can repeat. The y values can repeat all they want, but the x values cannot repeat. So if I were given this as an ordered pair, I would look at all of the x values and see, do any of them repeat? And in this case, the answer is no. None of the x values repeat, so it is a function. I would look at it as a table, and I would even easier be able to tell, do any x values repeat? And it's the same exact set of numbers. So this is a function because the x values don't repeat. If any of these were to repeat, it would not be a function. And then mapping, we usually see lines drawn, sort of like this. So this means 11 goes with -2, just like how it does over here. 12 goes with -1. Whenever you put in 13, you get -2. And whenever you put in 9, your output would be 7. So what we're looking for here is that each side over here only has one line coming out of it. So because each one only has one line coming out of it, it is a function. So this is one set of coordinates being written 3 different ways. And our question is, do the x values repeat? If the answer is yes, then it is not a function. If we ask ourselves, do the x values repeat? And the answer is no, that means it is a function. The next way to tell is if we have a graph. We're going to use this thing called a vertical line test. Remember, vertical lines go straight up and down. So for this, we're going to need a straight edge, such as a ruler. I'll be using a ruler. So the vertical line test is a visual way to determine if a relation on a graph is a function. So we can look at a graph, do the vertical line test, and see if it's a function or not. Let's do an example. So to do the vertical line test, I'm going to get my vertical line and I'm going to scan the graph and see if at any point are there 2 points above each other. So if the line keeps going forever and ever without ever having 2 points above one another, that means it's a function because the x value, so horizontally, there wouldn't be 2 y values, there would only be 1. So this is an example of having 2 points above each other, so that would mean it's not a function. So when I'm doing the vertical line test, I'm checking to see, are there 2 points above each other at any point? So in the original one, without this point, this is a function. Let's look at another example. So this is another type of relation. So what I'm going to do is I'm going to scan, and I see immediately This point right here is above this. This one right here. This one. Basically, the whole thing goes over itself. So that means this is not a function because x values are repeating. So right here I would have, let's say, this is 0, 1, 2, negative 1. Here I would have the point 0, negative 1, and I would have 0, 0, 1, 2, positive 2. So the x values repeat. You didn't have to write all of this, but I just want you to see that this right here, whenever they're on top of each other, means they share an x value. And so the big question is just, do the x values repeat? And that's from a table, from a graph, from the mapping, and from ordered pairs. You can tell by asking yourself, do the x values repeat? And since in this case, the x values repeated, that means it is not a function. Let's check out 2 more examples. These ones aren't in your notebook, but I wanted you guys to see what they look like. So here we're given a set of coordinates. So we have this point right here, this one, this one, this one, and then we have these. So we're checking to see, do these pass the vertical line test? Are there any points one on top of the other? So right here, this one is by itself. Keep going, this one is by itself. This one is by itself, and this one is by itself. Because no points are ever above one another, there's not ever multiple points, this one is a function. So it passes the vertical line test. So these 2 so far have passed the vertical line test. This one has failed the vertical line test. So now let's look at this last one. So this one right here, there's only one. Oh, but right here, this point and this point are vertical. They're in the same line, meaning they're on the same x value, meaning that these 2 would not pass the vertical line test. So this is, because these 2 points are right above each other, not a function.